Good evening. Welcome to this 5-day learning automation challenge. I am just waiting for people to join. We've been recording for a little bit now. Well, we started streaming a little bit for a couple of minutes now. So just going to give it a couple more minutes and then we'll get started. I will introduce myself while we're waiting. So my name is Mark Lee. I am a robotics and automation engineer, and I have been an automation engineer for over 2 decades. And I'll give you a brief introduction about my journey into automation. I didn't do, I suppose, what the normal route would be to automation. It makes it really difficult to break into automation if you haven't kind of gone to college and done all the really advanced automation courses. My career started off as an aircraft technician. We didn't have PLCs or control systems on aircraft, or not control systems that we had direct access to programming anyway, for obvious reasons. So I left the aviation industry and made my way into manufacturing, into factories, and I started my career at Toyota at an engine plant. And I learned there sort of how world class engineering happens at world class manufacturing. And that's where I got my first taste of programming PLCs and programming robots as well. And I found it absolutely fascinating. I loved the logic. I loved the idea that I could program a device which controls a whole machine, and this whole machine kind of does what I tell it to do, basically. So it was really interesting. I love the challenge of figuring out the steps that machine needs to take, and it's often a lot more complex than you initially first realize. But as you kind of build on your experience, your logic starts getting deeper and deeper, and the basics. Well, it all starts with the basics, which is what this 5-day challenge is all about. So, like I say, I didn't go the normal route into automation and engineer or well, automation controls engineering. I had to find a lot out the hard way. I found I really enjoyed automation. I wanted to do more of it, and I strived to learn what I needed to learn. And generally, it was a case of going on a PLC course and learning how to program something for, say, Siemens PLCs. However, there was some fundamental knowledge that is kind of missing when you go down that route like that. So a lot of people I've spoken to kind of get on the Siemens courses, or they go and pay for a course how to program something in TIA Portal or something in Allen Bradley or whatever brand PLC or robots that they're trying to program. But if you don't know the fundamentals, it can really trip you up. Trust me, I've been there. And that's why the whole kind of what I'm teaching in learning automation is the core fundamentals. And if you've got that, then you can apply it to any brand of device, hardware that you are programming, or any machine with a PLC or some sort of programmer inside it. So once you understand the fundamentals, I think that's really key. So that's what I am kind of delivering. That's what I'm hoping to kind of pass knowledge onto more, because it's the area that really tripped me up. Anyway, enough about me. Um, if you're really interested in learning automation, then you're in the right place, because this will give you that fundamental information. So, first thing I'm going to show you is this. Now, you may remember something like this in school. I certainly do. In primary school, we had drawing pins, wires, batteries, a lamp, and paper clips. And we made a basic circuit. And I don't know, as a kid, I loved it, absolutely loved it. So as you can see in this circuit, we've got the power supply, which is the battery, wired up to a drawing pin, which is our temporary switch. Sorry, a paper clip, which is our temporary switch. Drawing pin connected to this wire, which goes to our LED. Now, you may have used a lamp in school, but I don't have a lamp here, so we're just using an LED. And then the negative side of the LED just gets wired up to the negative side of the power supply. And quite simply, we make the switch, which is our drawing pin, and we get the LED on. Why is that? It's quite simply, we are completing the circuit. That's the most basic circuit you can do. You're either completing the circuit, so current can flow through the device and back to the power supply, or you break the circuit, so the current's got nowhere to go. So the current cannot circulate through, hence the lamp does not come on. Okay, quite simple, but why am I showing you this? You're probably thinking, I know this already, but why am I showing you this? Because people, uh, the people I've trained often forget that a circuit needs to be completed. The amount of times I've had, or I've set a challenge to, say, an apprentice or somebody else, and they create some sort of circuit or they wire something to a device, but they always forget to wire the negative as well. So they are not completing the circuit and they wonder why it doesn't work. So I am just reminding you now that this is the most basic circuit. We turn something on, we turn something off. It's as simple as that. And if you can understand this basic fundamental circuit, then you can understand control engineering as well. And this is where we're going to move on from in this 5-day challenge. Like I say, this is all about the fundamentals. So I'm starting with the real basics of this simple circuit that you can see here. Okay, so yeah, real basics, but that is really important that you understand that. And if you can understand that, then you've got every chance of learning more from that as well. Okay, so let's jump on to the screen. I'll share my screen. Okay, so I'm just showing you here now UniFCAD. So if you go to unifcad.com, this is a free website where you can do some simulated circuits. So you don't actually need any hardware for this challenge, but this is what we're going to be going over and developing our circuits for and moving on to inserting a PLC. So unifcad.com, unifcad.com. Like I say, it's free to use. There is a paid version, but you don't need it for this challenge. I will be showing you something where I can share two screens at once almost later on in the challenge. That is a paid for feature, but you don't need it to actually take part. You can view the pages separately, but don't worry about that. And like I say, it's free to do anyway. So when you register, when you sign up, and then you've got an account, then you can go ahead and move into the simulator at app.unifcad.com. Okay, so I'm going to show you. So tonight's lesson, actually, let me just tell you about tonight's lesson. It's to just basically replicate a basic circuit like you've seen on the wooden board with the lamp and the drawing pins. We're going to expand that a little bit further, but as part of that, I'm going to teach you how to just do the basics in UniFCAD as well, how to set it up for what we need for this challenge. So when you first start your UniFCAD app, you'll see something like this. Now, the first thing is this sheet isn't going to be big enough for what we need. For once we have a PLC in there, if you scroll down to the bottom on the left, you can see if I try and add a PLC in there, there's not a lot of space to put other devices in. So let's just get set up first. Okay. So on the sheet at the bottom, we can see here, sheet 1, there's a little gear that pops up just down there, if you can see it. Just give me a second. I think my screen's cut off at the bottom. Let me just. There we go. Okay. All right. So, yeah, if I hover down here now, you can see the little settings gear just pops up there. And if you click on that, it gives you the sheet configuration. We can give it a name if we want. We don't really need to in this instance. And what we're going to do is I'm going to set it to A3 vertical, not A3 horizontal, A3 vertical, just so we've got more space above and below the PLC. Honestly, I did this A3 horizontal the first time round, and it was just difficult to try and get everything in neatly. I wish they did custom sizes, or bigger sizes, A2, but at the moment they don't do that. So, and I'm just going to do full width bottom as well. Again, that just takes up less space in the corner, so we've got a little bit more space. Okay, so as you can see, we've now got an A3 vertical sheet. Okay, so just a little bit of an overview of what you see on the screen. On the top up here, when my pointer decides, on the top here we've got sort of different views. We're going to be going into schematic at the moment. Well, we're in schematic at the moment, and then we'll be going into ladder logic when we're programming the PLC. We've also got different selectors here. So we've got the pointer, we've got the hand, so we can move things around. We've got the three-phase cable wiring. We can add a wiring corner as well, which we'll do. We can add some text. We can. What does this do here? Show or hide references, which we'll come to in a bit when we start adding things. We can rotate devices and we can delete devices as we add them as well. And all the devices are over on the left hand side here. So we can see as we scroll around, we can see we've got all sorts of different devices that we can utilize. And there's enough in there for us to kind of create some basic circuits. And then when we're ready to simulate, we'll come to this in a bit, but there's the simulate button there. And if you do prefer a dark mode, you can click that and do the dark mode. However, I'm going to leave it on the light mode for this training. Okay, so first thing we'll do is we will replicate the circuit we just made on the board. So quite simply, we had a battery. We had a, well, let's just have a selector in. So a selector, a normally open selector, and we had a lamp. Let's see what we can find. A pilot light, LED. There we go. Okay, so we can just click on these, and when we click and let go, and then when we hover over the screen, we can see we have the device following the mouse, and wherever we click again, that device gets placed. If we click on it on the screen, it gets selected, and then we can rotate it, or we can delete it. So we've got a lamp already, so we're going to delete that. The button, I'm just going to rotate just to keep things a little bit neater. Move up. And then I'm just going to scroll in using the mouse wheel. Okay, and if you click the middle mouse wheel, it turns it into hand mode, so you can drag things around. Or it's the same as selecting the hand, I think. Nope, maybe not. Okay. Anyway, clicking the middle mouse wheel will do that. Okay, so we can move things around, we can line things up, and when we're ready, we can see if we hover over the sort of ends of the device, we can select and click, and this is where we start connecting things up. So we'll click it there and let go. And then we'll take it to the lamp and let go, and we'll take it back to the negative and let go. And you can move things around a little bit as well. Okay, so what you can actually see here now is, because we have a power supply, we can see from the positive, the line to the switch is red. That's showing that this connection or this wire is powered. This has power to it. However, there's nothing going to the lamp because the switch is open. So let's just go into simulate mode. Okay, we can see we are now running, and we can press the stop button to stop the simulation. So we're now running. Okay. So what happens now is if we click on the selector switch and let go, we can see the switch is now closed. The next cable goes red, indicating that there is power now going to the next device. The device, in this case a lamp, now illuminates. It's illuminating yellow because it's defaulted to a yellow lamp. And we can see that the blue shows the continuation of the negative side of the circuit. So we have the circuit created. And we can switch that on and off. And if we double click on that lamp, we need to stop the simulation, sorry. If we double click on that lamp, we can choose a lamp color. Good. Quite simple. We have a circuit, and we've recreated that same circuit that we had on the wooden board in UniFCAD. Okay, let's stop. Okay, I am going to delete all of this. So I'm going to select a device and delete, select a device, delete, select the device, delete. Okay, now machines are not powered by batteries. We know that. They're plugged into mains supply. So for our circuit, the first thing we are going to do is get we're going to have a conveyor system. In fact, let me just get something up here. Where did I have it? I should have got this up earlier. Just give me 1 second. Okay, so this is, sorry, I should have shown you this earlier, but this is the basic machine we're going to simulate in this challenge. It's a conveyor, so we're going to have a motor which drives a belt. We don't need to worry about the hardware, we just need to worry about the control system. So we're going to have a motor. There's going to be a start and stop push button station with a now we were going to have a white lamp, but we don't have the option of a white lamp in UniFCAD, so we're going to use a blue lamp. So we're going to have a blue lamp to indicate the status of whether the machine is actually requested to run or not. We are going to have a lamp tower with a red and green lamp on it, and that indicates whether the machine is physically running or not. We are going to have an access door, which is going to be protected by a reed switch. So that will detect whether the door is open or closed. And the conveyor is going to feed another machine. So we're going to take a signal from the other machine as well to make sure that that is okay to accept product. Because if that machine is stopped, all we're going to do is keep piling boxes into each other, and we're just going to have a jam, a crash, boxes may fall off the conveyor, we may have broken product. We want the conveyor to stop if the next machine is not ready to accept. Okay, so this is what we're going to go over, and this is what we're going to look at. So because we have a motor, we need 3-phase supply. Now, I'm not going to go into motor theory or motor concepts in this lesson because this is about control, not electrical engineering. So if you don't understand that bit, just take it from me. We need a 3-phase supply. So we're going to choose an AC, 3-phase and neutral, and phase earth. No, and neutral supply. Have we got a phase? 2-phase and earth. We'll choose the AC 3-phase and neutral. It's a shame we don't have an earth as well. Do we have a separate earth? Yes, we do. We have an AC earth. We do have a protective earth. It's not really needed in here. Okay, so we're just going to pop that kind of up in the top left corner for now. And if we double click on it, we can actually give that tag, which is automatically generated, a name. We don't need to. I'm just going to do it for neatness. is limited on characters, so I'm just going to call it three-phase. Three-phase. Okay. Yeah, it's limited on the characters it can display. Okay, so we have a motor. So let's go and get a motor. So we need the three-phase motor, and we're going to drop that in over on the right-hand side over here. Sort of, let's move it around about sort of D. Okay. Now, to run the motor, we need a contactor, and that either turns the supply to the motor on or off. So we can see here we have the three-phase contactor. So we're going to select that, and we're going to drop that in above the motor. Then to protect the motor, we have a motor circuit breaker. Again, for this challenge, we don't really need it, but let's wire it up as we would anyway. So we can choose the motor breaker three-phase and just drag that up as well to about B. Okay, now we can wire these in. So we can either choose individually to pull each wire to the next device, such as phase 1, phase 2, and phase 3, like so. And then I'm just going to separate those so we can visibly see each phase. Or if we choose that little three-phase wiring icon up here, then we can click on one, drag it down to the next, and as you can see, it's doing three phases all at once. So it just makes life a little bit simpler for us. Okay, so a contactor has a coil, and basically what happens is when we energize the coil, let me see, I've got a contact here somewhere. So what happens is this is a contactor, probably not the most best view, but when the coil inside gets energized, then it brings all those three sets of contacts over and completes the circuit to the motor. So we have a control coil, which is an electromagnetic coil. And when that is energized, it pulls the contacts over, it mechanically moves those contacts so that they touch and then send power down to the motor. So we have the contacts themselves there. We need a coil as we would have a coil in the contactor, and that's what controls the contactor. Again, if this is not making an awful lot of sense at the moment about what a contactor is, I do go into this on my full fundamentals course, so you might want to check that out. So we have the coil and we have the contacts. These are both part of the same device. So to make sure that the system knows that they are part of the same device, we need to rename the tags. So I am going to call this K1 on the coil, and I'm also going to call the contacts K1 as well. So they've both got the same name. Now what you can see now is this little bit of text here that's popped up. This is the cross-referencing text, and you can see it's also popped up there as well. So what this is basically saying is that this coil is related to this set of contacts, and it's in this location, 1.7. So it's sheet 1. It's column 7, which is kind of bordering 7 and 8, but it crosses 7 first, and it's in row C. So if I move that further to the right, so it's definitely in 8, you can see that the reference is now 1.8C. I'm just going to move that back for neatness. So we can see that this coil is physically related to these contacts. Now, if I move the coil around, it can be anywhere in this sheet. You can see it is still related to that contact. If you can't see this for any reason, please make sure that this show how hide cross references is selected to show. Okay, so we're going to leave it showing for now. Okay, so we need to control this contact coil. And the contact coil, just like the lamp in the circuit, needs a positive and a negative supply. However, coils are generally in a modern circuit 24 volts, but you can always double check that on your device because sometimes on older systems you will see they are AC relays or contactors with an AC coil, in which case it needs an AC power supply. But in most newer control systems, they are mostly 24 volt DC power supplies. So, first thing we need is a 24 volt DC power supply. And we have that here. So we have an AC DC power supply or a three-phase AC to DC power supply as well. We can use either one. One is single phase, so you'll take phase one and neutral, and that's like taking 240 volts and neutral from your plug sockets at home, or you can use the three phase. It doesn't really matter. I think for simplicity, we'll stick with the three phase just so we can just select it and drop it. And then we can just pull the three phases from above. So I'm going to select my three phase link, and in fact, before I do that, we need a breaker. In fact, no, I'm going to change it. I'm going to get rid of the three phase. I'm going to have the AC/DC single phase, live and neutral. We're going to move it down to about here. To protect that, we need a breaker. So we're going to have a two-phase circuit breaker. And we're just going to drop that just above it, like so. Okay, so now we're going to make sure we're not selected on the three-phase cable. Turn that off. And we're just going to do an individual. So we're going to choose phase one and neutral. I'm just going to move that over to the left and then move that down, just so it's obvious. We'll move this down a little bit and we'll connect the live to the breaker and the neutral to the breaker. Okay, so we've got a protective device. Oops. Put that in. We've got a protective device for our power supply. And what this gives us is 24 volts positive and negative power supply instead of a battery. Okay, so we still need to make sure that we connect our positive to our positive and our negative to our negative in order to complete the circuit. Now, if we simulate this straight away and we turn all our breakers on, we're just going to have a constant positive to our K1, so our motor will run. In fact, let's just show you that quickly. So I go to simulate. We need to turn our breaker on. Every time we go into simulate, we need to make sure our breakers are on to control our circuit. As soon as I turn this breaker on here, we have power to our power supply, which gives us power on the output of the power supply, powering our coil. As you can see, it's highlighted in red. And because the coil is energized, it closes the contacts of the contactor, which allows you three-phase supply to your motor. If I can get that to work. Yep. And we can see that the motor is now turning. Okay. Now, obviously, we've got no control over this. We cannot stop or start it. So let's stop the simulation. And let's remove this connection here. Select it and delete. Okay. Now, just like before, we are going to have a button to control when we want this to run. And we are going to choose a push button, not a selector switch, a push button. Because, and what have I done with that? Sorry, should have had that handy. But most machines will have some sort of start and stop push button like this. Start and stop. Okay, just like in our concept image, start green, stop red, and the little white sort of bit you see in the middle there is a translucent window. So on the back, we can connect a lamp so we can have a white indication there, and we can make use of that as well. So it's a push button. So you push it, you let go, push it, you let go. It's called a push button. Okay, so we are going to use a push button. Now, we're going to use a normally open push button so that when we press it, and what we will do is we will just rotate that, and we will actually call that start, and then we can wire that up to the positive side and then over to our coil. And when we click on simulate, let's reset our breakers again. So we've now reset our breaker, putting power onto our 24-volt power supply. As you can see, we now have the red to our switch, just like before. Let's turn the breaker on to, or the motor protection breaker. We'll reset that. And as you can see, we've now got power to the contacts, waiting for the contacts to close to turn the motor, which is currently idle. Okay, so if I just, let's just move it to there. If I click this with my mouse, you can see the contactor now is energized, or the contactor coil is energized, and the contacts close, the motor is running again. If I let go of the push button, it resets back to its normally open position, and the motor stops. Press it, contactor coil starts, motor runs, let go, the coil de-energizes, the contacts open again, the motor stops. Okay, so that's just like what we had before. We have a power supply switch. Where we had the lamp earlier, we now have a coil, but we're now controlling the coil for the motor. However, this is no good for our conveyor situation, because nobody ever goes to a machine and just stands there with their finger on the button all day. There's no point to that at all. What we want is the control system so that when you press the start button, the machine starts and you can let go. And then when you want it to stop, you use stop. Stops the machine and you can let go. So let's create that circuit. So we need a stop button as well. Now, a stop button is always a normally closed contact. And the reason why that is because if a contact fails on a button, it's more likely to fail open, so it means the contacts don't touch, and that means that you will never be able to start the machine if you've got a faulty stop button, which is better than a running machine that you cannot stop because you have a faulty stop button. So you always have to make sure the machine is in the safest condition. For that reason, we use a normally closed set of contacts. So what that means is, in its resting state, the contacts, just like the drawing pin in the circuit, would actually be touching to complete a circuit. And then when you press, it opens the contacts and it breaks the circuit. So a normally open contact, like the start button, you press to make the circuit. And a normally closed contact, like the stop button, you press to break the circuit. Okay? Again, we go into normally open and normally closed contacts in a lot more detail in my fundamental learning automation course. So you can dive into that in more detail in that course. And again, this is key information to understanding what normally open and normally closed means, because once we start getting into robot programming, PLC programming, you are going to come across normally open and normally closed contacts all the time. Okay, so let's just stop this simulation. I'm just going to rename this to stop. Save changes. We're going to delete this line here. Let's rotate the stop button. Move you over a little bit. Stop button up there. Connect that to there and that to there. Now we have a start and stop button. However, if we simulate, reset our breakers, we can see we can start the machine, but as soon as we let go of that start button, the machine stops. Again, this is not what we want. We're no further along than we were before. Okay, so this is where we need to start thinking about control and control logic a little bit more. And what we want to do is we want to start having a latching system to latch the machine in a running condition once it is running. So what we can do is we could go and get a relay. Now a relay is just like a contactor, as I mentioned before. It's got some contacts in it. It's got a coil in it. And relays are really important to understand because it's the basis of where PLC control came from. So just like we've got on the drawing here, with our contactor, we have a coil and contacts. We're going to do the same with a relay. Now, the difference between a relay and a contactor is a contactor is more robust and it's generally used for switching higher loads. Essentially, a relay and a contactor work in exactly the same way. So we will have a coil. And we will call our coil. Oh, let's exit the simulation, sorry. So we will name the coil R1 from relay 1. And then we will have a set of a contact as well, a normally open contact related to that relay. So again, we're going to rename that to R1. Save changes. And as you can see, we get that cross-referencing information below. So it's saying that this coil here is now related to this set of contacts. Now, wherever we put that contacts, you can see the reference here changes to wherever the location of the contacts are. So whilst they're physically connected, in the diagram, they can be anywhere at all. Okay. Now, we're going to delete this connection here to the contactor, and then we're going to rely on the relay contacts to bring that contactor on. So I'm just going to move the start and stop down, and then we're going to connect the top of that relay contact to the positive there. And then we want to power the relay. And get to negative because it's a coil. It needs that negative connection as well. Okay, so let's just simulate this here as well. So simulate, reset the breakers. And now, just watch what happens. We have the start push button. We press the start push button. We can see that R1 contactor coil energizes. And because R1 coil energizes, you can see over towards the right that R1 contacts close. which then switches the supply to the K1 coil, which then closes the K1 contacts, allowing the motor to run. But again, we still no further, because as soon as we let go of that start button, R1 coil drops out, which breaks the contacts over here to K1, which breaks the contacts here to the motor, so the motor stops. So we're no further along yet. We're just adding more devices. However, relays can have multiple sets of contacts. Sometimes they're limited to 2, sometimes they're limited to 4. Depends on the device you get. Sometimes it might only have 1 set of contacts. But different relays have different amount of contacts. Generally, you can get at least 2 sets of contacts out of a relay, or 4. So we've used 1 set of contacts, so we can actually use another set of contacts. So let's get another contact into our circuit. Let me stop that simulation a minute, and we can double click that, and we can also name this set of contacts to R1, 2. Now, as you can see, our cross-references now has 2 rows of information, showing that there's 2 sets of contacts related to this coil. One over here, and one over here. Okay. I am just going to rotate that set of contacts there. Now, what we want to do, this is where we need to start thinking about things logically. We press our start button. When relay 1 energizes, we want that to latch the circuit so it stays energized. So what we can do is we can use the R1 contacts to bypass the start switch. So we can connect it across the start switch like so. And then what this does is we press the start button to bring the coil on, but because the contacts will then close on R1, we will have an alternative route of power to the coil through the relay's own contacts, allowing us to let go of the start switch. That will maintain R1 energized right up until we break the supply to R1, which we do with the stop button. So let's put that into, let's simulate that so we can see it actually happening. Let's reset our breakers. And now we press start. We can see R1 coil is energized. Both sets of R1 contacts are closed. And now if we let go of the start, we can see everything remains energized and the motor is still running. Because we have this alternative route of power through these contacts to maintain the coil of R1. And because R1 coil is energized, R1 contacts are closed, K1 coil is energized, K1 contacts are closed, the motor runs. Okay, so if we press the stop button now, this then breaks this power supply to R1. And because that coil is now de-energized, we can release the stop button because the contacts are open here and there is no supply able to get to R1. So we've stopped the machine from running. This is a basic latch circuit. You will see this in physical control, and you will also see this in PLC logic as well, all the time. This was one of my first introductions to control logic, and whilst it's quite a simple process, I actually found it really, really fascinating. And even now, just every time I teach this, I still get a bit of a thrill from just understanding this logic, this control logic. I release the start button, it maintains itself. This relay, using its own contacts, provides an alternative power supply or an alternative path for the power to keep itself energized until we break it with the stop button. So we've got the start, latch is on, stop, it turns off. So that is the first bit of control logic for our conveyor system. Now, we did say that when this conveyor is running, if it's not got a signal from the next machine to say it's ready to accept, then we don't want it to run. Or if somebody opens the door, we don't want it to run. So we are going to add in a little bit more logic into this machine. Okay, so let's just stop the simulation and let's just move things over a little bit because we're just going to need a bit more space. View over there, like so, like so. And let's move you down. Okay. So what we're going to do is we're going to add 2 more relays into the circuit. So let's add the relay coil for 1 and 2. Okay, so let's rename this one to R2. Save changes. And R3. Save changes. Now, quite simply, we do not want the motor to run until... In fact, no, I'm getting ahead of myself there. So, R2 is going to be related... In fact, I'm going to add some text onto this. So, R1 is request machine run. Can I rotate that just for... Yeah. Okay, so that is requesting the machine to run. R2 is going to be safety or safe. Let's spell it right. Safety. Okay. So when the door is closed, the safety is okay. And then R3 is going to be for indicating that the next machine is ready. Okay, it's limited on text, so let's do next machine ready. Save. And we will rotate that. Okay, so these all need connecting up to the negative side. Let's just do it to there. And there. Okay. And for the safety okay, the door would have a reed switch on it. Now, a reed is like a magnetic operated switch. So when the magnet touches, it's in 2 parts. You'd have the magnet on the actual door itself and the reed switch on the frame. So as the magnet comes close to the reed switch, the contacts will close, so indicating that the door is closed. And as you pull the magnet away, the contacts would open again. Closed, open, close, open. Simple concept. There is no reed switches in this software, but it is just another set, or it's another type of switch. So we could use anything just to simulate it at the moment. And the best one to do so would be the limit switch in this instance. So we're going to have a limit switch. And some safety door systems do actually operate on a limit switch. So we'd have like a plunger that would go inside the switch and push the contacts closed to indicate it's locked. More on a gate, maybe, something like that. Okay, so we're going to have that. We'll just put that there. And let's double click on this and call it door switch. Or door switch, like so. Hopefully that indicates. Okay. And we'll connect that up to the safety okay. So if this conveyor had 3 access points, then there would be 3 door switches, and all 3 would need to be closed in order for the safety to be okay. That then needs connecting to the positive side as well, so it's got a power supply to go through the contacts. And then for the next machine ready, we would have a signal from the machine. It would go through an interface relay, but let's not get into that now. So what we're going to do is just choose a selector switch, when I can find them. Selector normally open. So we can simply switch and simulate when the machine is ready. So we can actually switch that machine ready signal on or off. Okay, so let's call that next machine. Okay, now we have our door switch to R2 and our next machine to R3. However, there's no contacts yet, they're not doing anything. We want K1 to not run if any of these relays are not energized. At the moment, we are only controlling off R1. So what we also need to do is have R2 and R3 into that circuit as well. So all 3 contacts are needed. So we're just going to delete that leg there. I'm going to go find our normally open contact again and just pop it underneath that one. And then one more underneath that one there. First contact is R2. And then the next one is R3. And as you can see, we have our cross-referencing again now. Come on. There. We have our cross-referencing there underneath our coils, relating to our new set of contacts here. Okay, so let's just wire all these in series so that if any one of these gets broken, you cannot have a supply to K1. Right, let's simulate this. Let's reset our breakers. And let's go for our start and stop latch. So we press the start. We can see we are latched in. I have released the start button. We are latched in. Relay 1 is energized. The coils are closed. The 2 sets of coils that we have, both here and over here. However, as you can see, the signal or the supply, whilst it has got through R1 contacts, cannot get through R2 and cannot get through R3 and cannot enable or energize K1 coil. Hence, the motor is not running. So at the moment, we can see the door is open. So let's close the door. Okay, so we click on that, the door is closed. We can see our safety is now okay. We get our safety okay relay is now energized. And because of that, we can also see our R2 contacts are now closed, and that enables the power to get up to R3. So at the moment, we can see that the next machine is not ready. So if we enable that by switching the switch, we bring R3 relay coil energized. That closes R3 contacts. And now we have supply to K1 coil, enabling the contacts to close, enabling the conveyor to run. So as you can see, what we've got now is quite a simple sort of control system whereby we can stop the conveyor, we lose R1, we can start it again, we get R1, the conveyor runs. However, if somebody comes along and opens the door, the conveyor stops because we don't want it to run with the door open. Close the door again, conveyor runs. And if the next machine stops for any reason, again, the conveyor stops. And as soon as the machine is ready, the conveyor can restart. Okay, so we have got a really simple circuit. We've got a really simple control circuit. We've put some logical thinking into this, and we've got something that you might actually see on a basic conveyor machine. And you might look in the control panel and you'll probably see it could be controlled with relays. You might not see a PLC in there. For something this simple, you may actually just have relays in like we have in our circuit here. And this is called relay logic. And this is what started the enabling of having logic within machines. As we go through this challenge, we are actually going to put a PLC in here, but it's really important to understand what relay logic is first and how relay logic diagrams are written to make things a bit simpler. So tomorrow, in tomorrow's lesson, we're going to have a look at relay logic or relay logic diagrams, so you get a better understanding of that, because that will make more sense when we start doing things in the PLC. For now, I'm going to set you some homework. Your homework is to register on UNIVCAD, get yourself an account, set up this circuit as we have here, and recreate it for the control system. And then tomorrow, we'll take it a little bit further. We'll add some lamps into it. We'll start drawing out the relay logic, and then we'll move on from there. Okay, I hope you found this insightful so far. I hope you found this useful and enjoyable. Once you start playing with this yourself, you'll realize quite how much fun you can actually have with this. So, like I say, your homework is to do that, and then send me a screenshot of what you've got, so I can just double check that you've done it correctly and that you've understood what you've learnt from today's lesson. Okay, that is all for now. I will see you on tomorrow's lesson.